So when you, all of you, please pay attention. So horizontal position is its initial position. When you release it, okay, so it will pass through vertical position also. Okay, so what is asked, that find the angular velocity of center of mass G when it is in vertical position. Okay, so when it will be passing through this position, vertical position, at that time, at that time, you, what is angular velocity of the point G. Okay, so uh, in short, you have to find the angular velocity of this link only, this bar. Okay, whatever is the angular velocity of this bar, the same will be the angular velocity of center of gravity. So you use the same principle, work energy principle. Okay, so how you will calculate the work, then how will you calculate the energy? Same formula you will have to use. How to calculate the work done? Okay, see, what force is acting in vertical direction? The force acting in vertical direction is nothing but the weight. Okay, weight of the
Yes, sir.
bar. Correct. Now you see that how much is the distance, how much is the displacement of center of gravity in vertical direction. कितना ट्रैवल किया उसने in vertical direction. So if you see, the distance traveled by the center of gravity is this much. Got it? This much distance it traveled in vertical direction. The force acting in vertical direction is mg. Okay, so say this distance is equal to h. So work done, that is your WD, work done will be equal to mg into h. Correct? Mg into h. Now what is this h distance? You see, the h is the
L by
distance.
2.
Yes, correct. H is the distance between point O and point G. So that is your L by 2. H is given as L by 2. So this is your work done. Mg into L upon 2. It is your work done. Now you have to find what is the change in kinetic energy. Change in kinetic energy. Okay. So same formula you have to use, that the difference between final kinetic energy is how much? One half I, as it is rotating, the bar is rotating, right? One
Yes, sir.
half I omega 2 square minus one half I omega 1 square, one half I omega 1 square. So depending on the problem, you will see that the bar is released from horizontal position, that is from the initial position. At that time its angular velocity was 0. Okay, because it was held here, it was held in horizontal position, and then it is left, it is released freely. Okay, so at initial position omega 1 was 0, angular velocity was 0. So now what is remaining with us is nothing but 1 half omega 2 square, 1 half I is nothing but again your mass moment of inertia about which point, the point about which the bar is rotating, bar is turning. See, so bar is turning about point O. So I will say that I want mass moment of inertia about point O. Okay, so suppose if you are given the mass moment of inertia about the axis which is passing through center of gravity, that is Ig. Okay, it is mass moment of inertia about the axis of rotation which is passing through G, but you need to find out the same about point O. Okay, so you will use here again the parallel axis theorem. With the help of parallel axis theorem you can write IO, mass moment of inertia about point O, will be Ig plus, okay, Ig plus what is mass of the bar and what is the distance between these two axes, uska square. Okay, so distance is L by 2, L by 2 का square, L square upon 4. Got it? Now just we need to know what is the formula for mass moment of inertia of the bar about the Ig. Okay, so that formula I will tell you, it is mk square. Okay, so in place of k square, L square upon, what is that formula? See, it is L square upon 12, right? Ig का फॉर्मूला क्या है बार के लिए? ml square upon 12. Okay, so I will write Ig is equal to, here Ig is equal to m l, sorry, okay, m l square upon 12. So radius of gyration will be your L upon root 12. L upon root 12 will be the radius of gyration for the bar. Okay, so now you use these equations, this formulae, and then tell me what is unknown. That is, what is unknown to us? We have to find out omega 2. What is the angular velocity of the center of mass when it is in vertical position? So find out omega 2. You equate delta E and work done. दोनों को इक्वेट करो, वैल्यूज पुट करो और फाइंड आउट करो ओमेगा कितना आता है. It may come in terms of like L or M, because these values are not given to us, so you may not get the number, but you may get it in terms of some other parameter of the bar. कितना आंसर आया है? ये दोनों को इक्वेट करो आप, डेल्टा ई और वर्क डन दोनों को इक्वेट करो. Why it is work done is positive? Because the displacement is in the direction of force. देखो फोर्स भी डाउनवर्ड एक्ट कर रहा है और डिस्प्लेसमेंट भी डाउनवर्ड हुआ है, तो वर्क डन इज पॉजिटिव.
Sir, root of 29.43 by L.
समथिंग रूट बाय एल. रूट ऑफ 0 कितना है? रूट ऑफ 3g, करेक्ट. 3g means 3 into 9.81, correct, by root L.
Yes, sir.
Yes, by root L. So if you solve this 3g, the answer is 5.4249, and the unit you write it like in radian per second. Okay, where L is in meter. L is in meter because to solve this 3g, you put the value of g as 9.81 मीटर पर सेकेंड स्क्वायर. मीटर पर सेकेंड स्क्वायर रखा है आपने, इसलिए एल को भी आपको मीटर में ही रखना होगा, रेडियन पर सेकेंड. ओके, रेडियन पर सेकेंड. दूसरों का आंसर आ रहा है? सैमुअल,
Yes, sir.
getting this answer?
Yes, sir.
Okay, others please practice. Okay, at least these two problems. Okay, then it is the end of your first module, and I will be uploading one assignment on first module soon on the Moodle, so you keep checking that. And one prerequisite test. So these two things will be on your side before IA. Okay, any doubt you want to ask or clear?
No, sir.
Okay,
All clear, sir.
so we'll stop here. Okay, I hope that you have given attendance in first session.
Sir.
Yes.
Yes, sir. Thank you, sir.
Okay, welcome.
Yes, sir.
Okay, bye.